Thanks for your patience. I hope you guys are all having a great time. Today, Dan Cornell is here. He's a principal from the Denim group, and he works on building, designing, and securing web-based systems. And he's going to talk about a problem that's really near and dear to my heart, because a lot of my customers have this problem, which is how do you connect to a database with the appropriate level of permission, so that way when your app gets owned, everything else doesn't get owned along with it. So with that, I'd like you to welcome Dan.
Thanks. Alrighty. And so Dan Cornell, I'm the CTO at Denim Group, and that's exactly what we're going to talk about. And this talk actually came out of two clients that we worked with that where tuning their database permissions was important. They were both under attack, and in addition to a variety of different kind of mitigation steps that we put in place, one of the things we needed to tighten up that we had admittedly been lazy on was some of the database permissions. And when we did it for these folks, it was a manual, giant manual process that we were certainly able to do, but I think what we ended up with was not as completely constrained as it could be, and it took a lot of time. And so, and we'll talk about some kind of DevOpsy type things and whatnot. But so an interesting question that came up around folks in the office was, well, how can we set these things up in an automatic way so that they have exactly the permissions that they need to have, but no more? And so we'll talk through kind of some of the process that we went through for that, as well as some things that we've done to start hopefully automating this process and making it much easier and much more scalable. And we've got some code that we've released that is starting along this road. There's a number of kind of deficiencies that we still need to work out, but it's a step along the way. For some reason, my default slide has a picture of me, so if you see someone other than this presenting, then you're probably wrong. One thing, I guess, to talk about just about my background, and that kind of shapes a lot of my perspective on this, is I'm a software developer by background. Spent a lot of time doing enterprise Java in the mid to late 90s. Spent a couple years doing .NET. The last couple years I've been very focused on security and how the code that you write, how that has an impact on the security of your organization or of your customers. But I'm a software developer by background, and I say that at the expense of my, I'm not a DBA by background. I'm not a sysadmin by background. I'm a software developer by background, and so I look at this a lot from a software developer's standpoint, and also a lot of the software that we create at Denim Group is very software developer centric, just because that's the type of folks that that we tend to attract. Who here, show of hands, who's deployed a web app to production attached as the SA or root user? All right. I have a feeling that anyone who's not raising their hand is a liar. Just because it's so easy. You mean to tell me people that didn't have your hands up, you'd never once? Like when you're in college, late at night, okay, there we go. We got a couple people, and so that's it's a very natural way when folks are trying to get things deployed. You don't get paid to deploy things. Securely, you get paid to deploy things, right? And securely is a nice to have, and high performance occasionally nice to have. But the focus is on nobody wants to push the deadline out because it's we can't figure out how the SQL permissions are supposed to work, and so hey, we're gonna push this deployment for a day or so. That doesn't work in most software development shops that I've spent time around, and so in a lot of cases, your security gets boiled down to the weakest link, and for a lot of web applications that get deployed, especially in organizations that don't have a really strong kind of configuration management and structured process for rolling things live, you see in a lot of cases that a potential weakest link is the level of security associated with the database users attached to the web accounts. Just a quick show of hands, background wise, who's here is a software developer by background? Oh, good, a bunch of folks, security analysts by background. All right, excellent. Everybody else, circus clowns, rodeo cowboy. Well, good. And so it's good from a software development standpoint. I'd actually be interested to know if folks are in a position where they can share some experiences about how they've worked at tackling this problem. Again, I'm just talking about some things that we've started to do internally to help make this process easier for the stuff that we're building. And like the reason that web applications are such an attractive target for a lot of attackers is because they have so much data. I mean, most of the web apps that I've built are a kind of a thin UI on top of some sort of relational database, and that's not, certainly not all of them. It's not that there's other interesting logic and things that are going on, communication with external systems, but like at the end of the day, the vast majority of the web systems I've built in the last 15 years are like, here's the database of the nouns that we've got, and we need to make some web screens to do the verb stuff that we want to do with that. We've got products in the database, and we want you to make it so that we can like sell products on the web. And like a big shift that has happened over the past, over that kind of same period of time is, this data has value. I mean, was everybody presumably in the keynote, before, looking at the goals, anonymous folks, a lot of the activities they've got where they're like embarrassing people by releasing data and saying, look, you're, for whatever ideological reason, you're, like we were able to get your data and so we're embarrassing you. If you, track folks that are involved in like carding and stuff like that, like, the data is what has value. Like getting root, may have value for an attacker trying to accomplish some set of goals, but there are a lot more situations these days where simply having access to the data, a lot of times read access, but also write access to the data, that fulfills whatever goal the attacker has. And again, web applications, a lot of times are front end for web databases, and if you look at the data coming out from the Veracode folks, from the White Hat folks, MITRE, you see the stuff published by OWASP. I mean, like SQL injection is still like a giant problem that's alive and well in web-based database applications. If you look at like the Verizon data, the prevalence I think has like tapered off a little bit this year. There's still an awful lot of records that are getting stolen because of SQL injection vulnerabilities in web applications. And therefore, like if you think about it, the kind of the mantra around our office is, if someone else can run SQL queries on your database, then it's not your database anymore, right? It's their database, because they get to pick the queries that are run, they get to pick the data that goes in, they get to pick the data that comes out, and so like choosing the permissions of the user associated with this web application or the database potentially has a huge impact on the security posture of the application and of your organization, depending on what type of data it sits on top of. Like I've got a buddy that I went to school with, and he runs a dev shop where they've got a couple folks onshore in California, and then they've got a couple of offshore teams that they work with. Do a lot of web development for clients, marketing sites, stuff like that. And he called me one day and he said, "Oh, Dan, you've been talking about the SQL injection stuff for so long. I just didn't think anybody actually did that." And I was like, "You really think I've been wasting my life for the last however many years?" Like, and I said, "No, but we found like my guys injected had these SQL injection problems, and somebody finally has been exploiting them and stealing data." And I said, "Well, what user did you have what user were you attached to the database as?" And he's like, "You're going to hate me for this." I'm like, "Well, I'm not going to hate you for this. You're probably hating yourself for this." He said, "No, it was the SA account." I said, "Okay, well, that means on SQL Server, that means the SA account can run things like XP command shell, which means that if you follow this through, you're going to need to like back up your data, clean it out, click the box, and start over again." And so, like, making decisions like that has a huge impact on the security posture of your org, because it has a huge impact on like what the implications of a breach are. Like most of the web applications that we look at, and this is probably in the like mid 5-figure lines of code to like low 6-figure lines of code. The bigger apps, tend to get, they're connected to more systems and they're doing more complex things in a lot of cases. But like for the kind of small to medium sized application we're looking at, they've got a single database user to access the database. And so what that does is it masks the identity of the user. I could be logged in as Dan Cornell, and the web application might have some concept of me being Dan Cornell, but all of my requests to the database get filtered behind, whatever SQL user dash app name or whatever, however that's set up. And again, too often we see that this user is hyper privileged, and why is this? It's either, again, we see it a lot in organizations that don't have strong controls over their production environment, where it's just like, get stuff, get code out there. The developers or the sysadmins and the developers and the DBAs. We've seen, and this actually came from the guys on our pen test team, as they said, like, hey, we run into a lot of organizations where like DBAs say, no, you get one app, you get one schema and one user, that's all I'm going to provision for you, right? And I said, like, really? He said, yeah, and it's usually the shops that we like really beat the crap out of during our pen tests, but that's, that's something that we hear over and over again when we push back on development teams and say you need to constrain these users, you need to have multiple accounts. That's the attitude that they get back. In a lot of cases, it can be too hard to figure out what permissions are needed, and this is especially the case in a lot of cases with like third-party code or frameworks. Anybody here ever done any work with Microsoft Commerce Server? Lucky, you're all lucky, first of all. But like the way that Commerce Server works is when you're in the admin console and you add new, category types and things like that, it starts provisioning, new columns in databases. When you, provision new catalogs, it's making new tables. And so in a case like that, just for the software to operate properly, the way that the system is architected, it needs a very high level of privilege, DB owner type access for at least certain types of use cases, and so that can make it really hard to try and constrain these these permissions, because it's like, hey, when the administrator goes in and tries to add a new catalog for a promotion or something, if we've got the database user constrained, that breaks, right? And you can't break the application. We'll talk about some things that we've started to explore to mitigate this stuff toward the end of the talk. So this is a hard problem, and the result is that if you've got your application attached with a high privilege user, any sort of SQL injection vulnerability is potentially going to give them control over the entire database, so that they can pull all the data in the database, they can update any things they want. You see that with the web SQL injection worms that are jamming like nasty ActiveX control stuff and things like that in there. You can map up the schema, insert, update, select, delete, kind of like to the level of creativity and the level of effort that the attacker is willing to expend. And so like the whole concept of confidentiality, integrity, availability is no longer something that applies to the system that you've got, because folks can delete data, which is going to impact availability. They can steal data, impacting confidentiality, modify stuff, integrity. It can even be automated. We'll look in a couple seconds at the SQL map tool, which is like really smart. If you can point it at a SQL injection vulnerability, like it's really clever at figuring out how can I manipulate the query that's being run in a blind way. How can I manipulate this query and start to like map out what's in the database? Has anybody here ever used SQL map before? Yeah, really cool tool. And so we'll show kind of the difference between two different runs on an example application. But like that's a really interesting tool to run. And I'm not normally like when we're talking with folks about like the implications of a pen test or something like that, I don't like to get in the game of, okay, well for this cross-site scripting vulnerability, show me how you'd exploit it. All right, and you spend like 20 minutes figuring that, like, okay, I'll fix that one. For the next cross-site scripting vulnerability, prove to me that you can exploit it. It's like, but like sometimes if you're trying to convince people that vulnerabilities are things that they might want to fix, SQL map, let's just say it makes an impression. When you can get a good run of it and say, with this automated tool that I pulled off of SourceForge or whatever, we're able to actually make a copy of your database and pull it back over here. Based on this one vulnerability that we found. So that can be a handy thing. Again, don't like to get into the like vulnerability by vulnerability example exploit game, just because that's not a real great use of time. But again, SQL map makes an impression. And we also see again applications sit on top of multiple databases, and so if that database user has to have permissions across multiple databases, SQL injection vulnerability in one application can all of a sudden start impacting databases in other places that you might not even really be thinking about. So we've got like to kind of demonstrate the process that we're trying to get in place for our applications. I've got a kind of a crappy PHP web application. It's a little e-commerce system, and it's attached to a MySQL user with like grant all on this user to let them do stuff. Like all this code is available online. I've got a GitHub repository link that might change slightly, but it's all like both the analysis code and the example code and the little helper utilities stuff is available online. And the slide deck will be available online too. So if you want to set this up, I just put those in there so that you could, not have some troubles that I've seen people have setting up the environment in their local stuff. And so, what's wrong with the target application? Well, we can take a look at it. and go around and look at the example app. And also what we're doing, this is running in Firefox, but all the traffic is running through the Zap proxy, OWASP Zap proxy, which is a proxy tool like Burp Suite or WebScarab. Has anybody here used Zap before? Yeah, excellent. This is like the side of the room that has all the cool toys. I like Zap. I think it's a good replacement for WebScarab, which hasn't been updated in a while. It's not as good or polished as Burp, but it's also free, which is nice. And it has a little bit of automated attack capability that you also find in Burp, but it's a little bit of automated attack capability. That's what we use for all of our training classes now, just because it's got some kind of additional capabilities over the stuff that we used before. But again, we can go in here, we can add paper clips to our cart. Go back to shopping, add some more things to the cart. So we want to check out. I guess we're logged in as a user here, so view cart. We're going to check out. Place our order, go back, home, log out. We can also create a new user. And so that's basically all the stuff that the application does. What that's done here is it gives us, again, inside of Zap. Zap now knows kind of mapped out where the different parts of the application are. So we can go here to active scan mode and just kick off a scan. Let the application go and bounce stuff around this, and along the way it's going to find a couple things that it doesn't like, including a bunch of SQL injection vulnerabilities in different places, as well as fingerprinting opportunities. And so, like, big surprise, my example application had SQL injection vulnerabilities in it. Amazing. And so, given those vulnerabilities, right? So now we know that there's some sort of a problem where an attacker is going to be able to execute, have some control over the code that's running, in the code that's running on the database. We can use SQL map to go in and see what we can find from that. So, if we go to, there we go. Maybe we'll. Oops. Basically, we can just run SQL map against one of the vulnerabilities that we found. Goes along and does all its stuff. Don't need to worry about that. So you see here it's starting to pull back data out of the different data tables. It's really, really super clever. And you see what it's also able to do is it's going and trying to figure out like the different databases it has access to, the permissions that it has, and so on and so forth. So we'll let this thing kind of run its course. But the important thing to understand or to see is like with this like two free nice automated tools that we use just to poke around on something. It's been pretty easy for us to start to retrieve a lot of information out of the database because we built a database user that was that had grant all permissions on it, which is not, which is something that we see a lot in development environments and something that we also see a lot that gets promoted into production environments. And should be just about finished. There we go. Okay. And so what we're going to see, and we'll look at the results here in a minute, what we see is that with this command, so again, all the commands and stuff are inherent in the slides. If you want to rerun all of this stuff, we basically can retrieve all the data. So we can pull back the usernames and passwords, we can pull back the order history, we can pull back their credit card information. Like just doing these different select queries, we can pull back like a copy of the database and the schema, as well as a bunch of additional permissions and things like that. And so common vulnerability, freely available tools, like very serious impact. And that doesn't even start to explore the types of things that you could do if you were updating records, if you were deleting records or inserting records. Again, like updating and inserting records, we could go into the product catalog and we can put a lot of HTML and things like that in there that might have malicious ActiveX controls. If we can delete records, we can make orders, make them go away. If we can update orders, we can do the same type of stuff. So all kinds of really nasty things that that happen to this application. And so like that's not a good situation to have where like this is kind of the norm of how web applications get built and deployed. So the question then is, like, that was with a powerful database user. And again, not with the root user where they'd have access to the entire database, but with the user that was created that was given specific permissions, although very high permissions, over that one specific database. And so, it's desirable from a defense in depth standpoint to constrain the permissions that this database user would have. But to do that, we really need to know what access a legitimate user needs. And so, well, what are we going to do if we want to figure that out? We could go ask the development team, right? Good luck. Good luck with that, because in a lot of cases, different developers work on different parts of the apps. Different developers have different coding idioms that they've used. There's parts of the app that were built by folks that aren't around anymore, and and in a lot of cases, developers these days are abstracted from knowing the type of SQL stuff that they're running. Has anybody here used Hibernate or some other relational mapping thing? Like, have you seen the actual queries that run that support your Hibernate stuff? Like, that's some wacky stuff, right? And it's a lot of stuff that you wouldn't necessarily guess that is going on. Similarly, anybody who's ever worked with a lot of these kind of content management frameworks that have modules and plugins and stuff like that, has anybody ever watched the MySQL queries that run when like a Drupal instance comes up and running, right? Like all kinds of crazy stuff that's executing on the back end, and a developer is not going to necessarily know anything about that. You can go ask the DBA. The DBA, they may know even less about it because they're not the ones that wrote the application. And both of those approaches don't really scale. You can certainly go and look through the code, and that's going to give you a starting point. But that's also kind of an error-prone, way to approach something like this. And so, like the question that we had, and again, this came back to two instances where we were trying to go with two different production applications and say, we've got some constraints in place, but we want to make these constraints even tighter as one of a variety of things that we're doing to harden this environment against this attack that is ongoing. One interesting article that we found, and again, you can get the slides online to look at this stuff, but looked at some, like how do you calculate the effective database privileges? If I can look at a user and look at all the grants that they've had given to them and like follow that along, how can I figure all the stuff that they have access to? There's also a guy named Pete Finnegan, who's an Oracle guy out of the UK, Oracle security guy, and he's released some tools that can help to automate this. Given this role, given this user, given this privilege, like how do I spiral out and figure out the different things that I can, what are the different operations I can perform on the database, based on knowledge of the schema of the database as well as this access control that I know that I've got. That's kind of less than ideal for what we're trying to do, because the question isn't what can this user access. Instead, the question is what should this user be able to access, right? Like answering the question what can this user access might be very valuable in an incident response scenario. If you've got to make a determination, do we have a PCI breach where I've got to say that I lost credit card numbers? Like certainly being able to say for these users with these permissions, like let's run down the tree and figure out here's all the tables and stored procedures and things that we've got access to. But that's a little bit the reverse of the problem that we're trying to solve here, which is to figure out for this given user, for an application, what are the, what should they have access to? And so, so a little bit different problem. Not, it's not that those tools are not helpful in exploring and understanding more about, access to the database to highlight, like, oh yeah, well this role or this user should never have access to this table. We can turn that off. But I think a better solution is kind of to find a way to shrink wrap the application, to figure out, like, the application needs to do these things. Let's figure out how to, like, fit something to it like a glove, or shrink wrap the permissions around that so that it only has the permissions that it actually needs to execute its job successfully. And there's a couple, like, there's other tools that do this, not necessarily surrounding database stuff, but in different environments. Any .NET developers ever use the .NET permission calculator tool, right, where it can look at an assembly as well as associated assemblies. It does some static analysis to see what calls are getting made, and then it maps those to the CLR runtime permissions that that assembly should need to run, right? So that's handy to look at it. And so instead of running in full trust mode, which is a scary, dangerous thing, especially if you're running like a shared ASP.NET environment or something like that, this will let you, like, look at an assembly and figure out, like, here's all the stuff that this might do. Similarly, there's a cool service, as well as kind of some research that was released called Stowaway, and this is geared toward finding Android applications that have excessive permissions, right? So if you install an Android app on your phone, like, why does your flashlight app need to have access to your address book in the internet, right? To, like, light up your room. That's probably not required, depending on how you use flashlights. But a lot of Android apps, like malware and stuff like that, need or ask for those permissions, and a lot of folks will click by them. And so Stowaway is a tool that, again, does static analysis of an Android binary, which is super easy to do, and has a list of signatures. Hey, if you're going to call, like, check the GPS, that means you need either location find or location course permission. That's what it's going to ask for in the case like this. So very cool tools that are doing similar type of stuff here, saying, let's figure out, like, the exact set of permissions this application should need to know about. A challenge, just kind of from the standpoint of what we were trying to do, was that both of these tools rely on static analysis, and that's good from a coverage standpoint, but if you look at the way that web applications are created, the way that web applications build the SQL statements they're going to execute, like, that all of a sudden gets to be a really hard problem to solve by analyzing the code, because you've got to, like, know what strings are going to be that are going to be appended together. You've got to know how Hibernate works and what it's going to try to do on the back end, which, if you change versions of Hibernate, that may change. And so a static approach to this problem, kind of within the constraints that we had, was not a great solution. And so the alternate approach that we looked at is, like, let's watch, for an acceptable set of user transactions, right? For traffic that we know to be benign, let's see if we can get a comprehensive set of exercising of the different use cases in the applications. Let's see what SQL queries resulted as a result of that benign web traffic. And then based on that, let's create user permissions based on this, because that, again, the hope is that's going to show us, here's everything that needed to happen, here's everything that we needed to touch in order to have this successful run of the application. Let's make permissions that are only going to let us do those things. And again, static analysis in this case is going to be, like, really hard to get right. There's certainly drawbacks to potentially trying to do this in the dynamic manner that we're looking at here. But, like, static analysis, even for, like, the PHP code and stuff like that, you would have to have, like, insight into, like, the state behavior of, like, strings as they flow through the application. Like, that would be, the IBM guys tried that a while back with some kind of, like, string calculus stuff. It's a really hard problem, to solve in that way. Plus, if you look at, if we look at the applications, like in this case, we've got one or two apps that are Groovy on Grails apps. We've got, and then in addition to that, we've got, like, pure Java apps. And so, like, this is not something we could do, statically. Maybe we could do it based on the binaries, but it wasn't something where we could just, like, look through the source code and figure this stuff out. So what we put together was a tool called SQL Perm Calc, and what it does is it basically, you give it a set of SQL statements to say, I need to know the security requirements that you would have to have filled if you were going to execute these SQL statements. It's a couple hundred lines of Python, based on a really nice SQL parser from Andy Elbrick. So thanks to Andy over in Germany or wherever he's at. What's that? I'm sorry?
Can you make that larger?
Oh, make let me see if I can make this to show the whatever.
Slide view mode?
What's up?
The viewer mode?
Oh yeah, when we went in viewer mode, it went back and forth and wouldn't, like the projector wasn't working. And this will all be available online, or if you give me a card, I'll email them to you. It's all, don't worry about copying down the details there, because we'll send all that stuff along. It's not a problem. And so, so basically, it's a script where, along with some helper utilities, like right now that support MySQL. So basically, we can go into MySQL, turn on logging. Exercise the application, through an approved set of behaviors. Take those SQL queries that got executed and determine, what tables did we need to touch, what columns did we need to touch, and what access did we need. And as an aside, I'm a kind of a Java developer by background. Is anybody here a Python person? A couple of folks. Like something's said to be Pythonic if it's like a clean and nice looking Python that looks the way it's supposed to. SQL Perm Calc is currently Pythonish, which is slightly different. One of my guys who's helped me with this is like, yeah, you put all the code in the source in an SRC directory, like that looks really a lot like Java, and I'm like, well, that's because I was originally a Java guy. So they made fun of me in my office for a while, but that's fine. But that's I've actually got a set of recommendations from him that I'm going to be cleaning up and checking in the next day or so to make it more Pythonic. And again, we've also got some support tools. Like for MySQL in production, you don't want to have, like, it's not considered a best practice, it's considered an anti-pattern for performance to have query logging turned on, because that means every time somebody runs a query, which hopefully people are doing lots of all the time, you either have to append that to a file, or as we're doing, we put it into a table just because it's easier to manipulate and dump the stuff out in a format we wanted. And so this isn't something that I would make part of your like normal production routine that you've got kind of running every day. I mean, if it doesn't unacceptably negatively impact your performance, I suppose you could do that. But it's something that is going to have a performance impact such that it's kind of clearly labeled everywhere they talk about doing this, like don't do this in production for an extended period of time. We can also retrieve the MySQL log again. Since it's in a table, we can run a query against the MySQL database, filter that a little bit and dump the stuff out in a format that we want, which is good. And then there's another script in there that'll turn MySQL logging off. And so the process that we go through is we stop the web server, turn on MySQL logging, turn the web server back on so that we can see if there's any like startup sequence for the application, exercise the application, run it through hopefully a representative set of unit or acceptance tests, retrieve the logs and turn off the logging, and then take the logs off to the side to do some analysis of those. One of the things that we do quite a bit of in our shop is automated acceptance and regression testing using Selenium. I don't know if folks use that in their shops, or if you've got a HTTP unit or HTTP runner or something like that. Like that's something that has made like looking at an approach like this a lot more possible than it would have been otherwise, because basically at the click of a button or running a script, I can get a good set of user interactions with the web application, which leads to the set of database interactions that we want to be able to test against. And so that's really handy. If you don't have that, then every time you want to calculate new permissions, you have to have somebody sit and like monkey test the application, which is not as good. And so from that, then we calculate the different permissions. And right now, we're only looking at select, insert, update, and delete, which for certain applications may be acceptable. For other applications, you need to go beyond that. Select permissions are, you can control them either on a table-wide basis, where, hey, I have select permissions against this entire table, but in MySQL, you can also constrain it to a per column basis, so that you can say, hey, I'm only able to select like these 3 columns out of this table. I can't see other columns in there for this given user. Another thing though to know when calculating permissions, if you're using where clauses where you're trying to match against columns, you also have to have select permissions for those tables and those columns, so that you have the appropriate read access to even if you're not returning those columns to the user, you have to be able to select and see those columns. And so that's something to pay attention to. And so, again, we're looking at right now fairly simple statements. Select star from my table. Select a couple columns from a table. So on and so forth. Insert permissions are done in a similar way. You can control on a table-wide basis. You can control on a per-column basis as well. And so you can make it so that certain columns can't have, people can't insert. Like they have to take the database defaults. They can't override certain things. Yeah. update, again, you can control that on both a table-wide and per column basis. What users have the ability to write stuff to, and so people may have the ability to create things, but not go and modify them. And so that can be good for things like timestamps, where you want to differentiate between people that are creating creating things. Certain users may have the ability to create, but not go back and modify those things later. And again, if you're doing updates that have where clauses, those are going to have implications for the select permissions needed for the application as well. And finally, delete. Delete permissions are a little easier because they are in a certain way because they're only table-based, because they destroy an entire row. Like you can't destroy an entire row, but like leave a couple columns. And so delete permissions are done on a per table basis, but have, again, the same implications for where clauses with regard to select queries and things like that. So a note about wildcards: obviously a delete always impacts all the columns in a table, hence it only has table level permissions, not column level. Select and insert sometimes impact all the columns in a table if you're doing a select star from my table, or if you're doing an insert into a table and you don't specify the columns that you're putting things in. Like right now, our implementation doesn't know anything about the actual database schema, and so it tracks situations where it knows all of the columns in a table have to be, you have to have a certain type of access. That shouldn't cause problems, but like right now we're operating, or our code at least operates independent of specific knowledge of the database schema, and so we can't say, oh, you got access to all the columns, and I know that these are the 20 columns that are in that table. That's something that we might look at doing. Down the road. What we can do is basically run our script, and we're running a little short on time. Where we can go over here. Those are the SQL statements that resulted from our run, and when we run those, what we find here is that for the run that we had there, we have no delete permissions, this set of select and insert permissions were required. Inserting into commerce order, commerce user, credit card, selecting from commerce order, commerce user, product. But an interesting thing was, like with the use cases that we looked at, this user never needed to be able to read the data in the credit card table. So before, whereas what we saw is like SQL Map is able to bring back an entire copy of the database, including all the credit card data and the credit card IDs. With the constrained permissions, it's not able to do that, right? And so, like one of the handy things that we're through going through and generating these rules, we're able to see is, like this is a fairly small set of stuff. Like we still get to see a lot of things. We still can see all of the usernames and passwords in the database. This particular app has the passwords not hashed or encrypted or anything like that. They're just in the clear. And so the impact would still be pretty serious because you've lost arguably PII and things like that. But in this case, you haven't lost credit card numbers. And I'm a little ahead of myself. Like once we know what that model looks like and we know what capabilities MySQL has, where we can say like, hey, I know I need to be able to perform these operations on these tables and these columns, then it's pretty easy just to auto-generate the grant statements that you would need. So we basically create this user here. It's the user is called SPC_public low, and we can automatically generate those. So if you create that user with no permissions, you can run these grant statements and automatically create set the user so that they have the level of access that that directly reflects the analysis we did on the queries that were being run. Again, we're trying to figure out like how can we automate this to the greatest degree possible. Because again, spending a lot of time on this is not good. Applications are very dynamic, and we'll talk in a couple minutes about like some DevOps type stuff that we've been looking at. So what's the impact of these slimmed down permissions? The rhino who wants to be a unicorn. Can't remember what site I got that off of, but so basically, if we rerun SQL Map, we can still recover a tremendous amount of data because the user that we have still can see a lot of stuff. And so SQL injection, it's not that we've made SQL injection not important, but we have made SQL injection. We've taken some of the fangs out of those SQL injection vulnerabilities because we've got we may have a crappy application, but we've got this compensating control in place, which is the very constrained set of database permissions. And so like we've eliminated these update or delete access to tables, which is really nice. We've limited insert access to only certain tables. And so, the hope is that like folks can't insert into products or modify products, and SQL worms can't come in and infect the site with malware. If you look at the different operations, all the create things that you do are either like buying orders or creating users. It would be specific to one user, not seen by every user on the site. And so, like with these constraints, what we've got is definitely better than it was before. And it's a so that's nice. That's better. Not perfect. And it's also not something that I would like turn on our production servers today for reasons I'll talk about in a minute, but it also gives you some insight into database usage. Like right now, do you have a clue of what like database assets your different things are using? There was like one or two folks who had talked like, hey, I've watched Drupal turn on and all like the maniac stuff that's going on in the background that like the admin site needs to have as it like plugs in new modules and stuff like that. It's also something where you can do some forensic review over time. If you've got the set of permissions you think you need to have, well, if I can compare that permission set with something that I pulled out of production, if I turn logging on for 5 minutes or some period of time, I can create a new set of permissions and I can compare those to one another and find out, hey, did permissions get used in production over this run of time that I didn't think it needed to have? You can also compare multiple users and roles in applications. And so, one of the things that we've seen, and these are actually for these two different clients things that we've looked at. If you've got multiple applications that are accessing these databases, and we've got a public application and an admin application, those have different controls over what traffic can reach them, and so we also want to have different controls over what database assets each of those things can look at, because the admin user can have better, is going to need to have better access because they're going to need to be creating and modifying and doing stuff like that, whereas the public site should really be read only, right? And so there should be no anything bad going on with the potential implication of a SQL injection vulnerability. Another application that we looked at, we couldn't change the code, but we did have the ability to host two versions of the site in different VMs. And so each application thought it was a full up and running application, but we shaped the traffic that went to them. Again, so we had a public VM that was essentially a read-only file system and a very constrained database user, compared to the admin site or the admin VM where you had to come in traffic routed from a certain from a certain place, and that had a database user that had more expanded access, and that was working with I don't know if anybody familiar with like Robert Hansen and James Flom, who run Arsnake. They run or used to run like hackers.org and slackers.org. Like they're doing some really cool stuff with the infrastructure that they created to do that, using different like jails to virtualize stuff to say, if you can't change the code of your application, let's change the configuration that's public facing so that we can like minimize the impact of any vulnerabilities. And so that's some cool stuff. There's some limits to this approach. This assumes that all the database assets we touched were the ones that a legitimate user that all of the legitimate user is going to need. So if we miss something, we're going to see runtime errors, and that makes people scared and sad. Likely when code gets changed, we're going to need to recalculate this stuff. That's why automation, I think, is really important. And this is also a case where like the unit and regression test suites that we have been really helpful. And I don't know if anybody's seen Josh Corman's talk about rugged DevOps. Really cool stuff, looking at like how as you're forced to deploy things to production more quickly, how can you also increase security while you're doing that? So if you can catch him around the conference, definitely do that. Really, really interesting stuff that he's working on. Another challenge is many applications require a lot of access, so the security benefit might not be as great as desired. The example application, hey, we still lost usernames and passwords, and this is my trumped up example. So like how bad does it get when you hit the real world? Again, if you're dealing with a Microsoft Commerce Server or Drupal or something like that. Right now, in SQL Perm Calc, we only support basic SQL functionality, select, insert, update, delete. The parsing is still pretty rudimentary. We're not doing a good job of looking at joins, subqueries, and stuff like that. That's just something where we've got to run more kind of complicated stuff through. With a goal of ours being to look at some of our apps with the way that Hibernate is generating. That we use a lot of Hibernate, and so that's kind of like our next waypoint that we're heading toward. Is I want to be able to consume anything that Hibernate dumps out. And if we can do that, then I think we've got it at a level of maturity where I think it's going to be much more generally useful. Also, right now we're only running on top of MySQL, and that's reflective of not all of our environment, but a lot of work that we do. Next steps, again, improve the SQL supported by the parser to support more real-world SQL. This is kind of scripty right now, and it looks like I wrote it, not one of our Python guys. And we want to support more databases. This is all available in a GitHub repository. I'm going to move the repository that it's in, so by the time the slides go up, I'll have the link to the permanent home for this on there. So feel free to take it down and let me know. And I think I have like 32 seconds for a question, a question or two. So if folks have any questions, please let me know. Anybody? Totally self-contained presentation. Everybody's going to check the links later because they figure that's where all the answers to questions are. Anybody? Anybody? No? All right. Well, good. Well, I'll be wandering around here for the next today and tomorrow before I got to roll out of town. So if you've got any questions, please let me know, or just email me. I'm dan@denimgroup.com, or you can follow me on Twitter @DanielCornell. Feedback is the breakfast of champions. Love to know. All the feedback sessions are being done in SurveyMonkey. So please hop online and give some feedback on the talk. Thanks a bunch, guys.